Hello everyone. Welcome to another session of learning. Today, we will discuss all about percentage composition of compounds. And at the end of our lesson, you are expected to determine the percentage composition of a compound given its chemical formula. So ano nga ba ang percentage composition? For you to understand better what it is all about, let's do the first step, which is to understand what is compound. By means of studying these illustrations of combined elements and what compose them. As you can see, we have here a chemical formula of water and rock salt. Water is composed of two elements, which are the hydrogen and oxygen. The hydrogen is presented by capital letter H, which indicates its symbol, while the oxygen is presented by capital O. If you look at chemical formula, you will notice that hydrogen symbol has a subscript of 2, which indicates that this element is composed of two atoms in water molecule, while the oxygen does not have subscript, which indicates that the number of oxygen atom in water is only 1. On the other side, the rock salt is composed of two elements, the sodium and the chlorine. Sodium is presented by symbols capital N and small a, while the chlorine is presented by the symbols capital C and small l. We will notice on the chemical formula of rock salt that the symbols don't have subscript, which means that both of these elements are consisting of only one atom. Once the given elements of water and rock salt combine, compounds are formed. Thus, compound means combination of two or more elements since it is composed of two or more separate elements. Now, let's check if we really understand what is compound by means of answering exercise number 1. Just simply tell whether the following is a compound or not compound. Number 1. Hydrogen chloride or HCl. Correct. It is a compound. Number 2. Gold or AU. Correct. It is not a compound. Number 3. Methane or CH4. Correct. It is a compound. Number 4. Calcium carbonate or CaCO3. Correct. It is a compound. Number 5. Phosphorus or having a symbol of P. Correct. It is not a compound. As given emphasis, the main characteristic of compound is having combination of two or more elements. Now that you really understand what is compound, let's now move on to percentage composition. Let's look again with our examples a while ago. The water and sodium chloride compound. By means of percentage composition, we can able to find what is percentage of each of the element that compose them. So why do we need to find the percentage? It's simply because it is necessary. Like for example, in the laboratory, you may perform experiments that will require to prepare solutions or verify the purity of substance, such as the 10% solution salt. If you are asked to prepare it, you dissolve 10 grams of salt in a 90 grams of water to make a 100 grams salt solution. So why 100 grams? Because percentage is 100 since it is an amount 100 or by 100. Thus, you need to know how to calculate the percentage composition of compounds using the formula mass percent equals to mass of element divided by mass of compound multiplied by 100%. But before we move on to calculation of percentage composition of compounds, here are the important things to remember. First, identify the elements in the given compound. Second, Identify the number of atoms of each element. Third, identify the atomic mass of each element. How are we going to do that? Simply use your periodic table of elements. Just like, for example, the element hydrogen. After the name of this element, you can see a value of 1.008. This indicates the atomic mass or atomic weight of that element. Fourth, find the molar mass of compound. Remember that the molar mass is also the same thing as the mass of compound. To find it, just simply multiply the number of atoms of each given element and its atomic mass. Then, get the total of masses of the elements in the compound. And lastly, use the formula mass percent equals to mass of element divided by mass of compound times by 100%. To assess if you now understand the concept of percentage composition, let's do exercise number 2. On your piece of paper, write true if the statement is correct and false if it is wrong. Number 1. Percentage composition tells by mass what percent of each element is present in a compound. Correct. The answer is true. Number 2. Identifying element in compound and its mass is not necessary in computing percentage composition. Correct. The answer is false. Because, as we discussed a while ago, element in a compound and its mass is very important in calculating the percentage composition of the given compound. Number 3. For computing percentage composition, use the formula mass percent equals mass of element divided by mass of compounds multiplied by 100%. Correct. The answer is true. Now that you already understand the concept of percentage composition, let's now move on to the sample calculations. Let's determine the percentage composition of the following compound. First is water, second is sodium chloride. In example problem number 1, water is composed of two elements given its symbols naming hydrogen and oxygen. In identifying their number of atoms, we can see 2 as a subscript of hydrogen, indicating that we have 2 atoms of hydrogen in water and only 1 atom of oxygen since there is no subscript there. In here, the atomic masses of both of these elements are given. The atomic mass of hydrogen is 1.008 gram per mole, while the oxygen is 16.0 gram per mole. After identifying the elements and their atomic masses, let's now get the molar mass of each element and the whole compound by multiplying the number of atoms of each element to its atomic mass. So, we will multiply the number of atoms of hydrogen, which is 2, to its atomic mass, which is 1.008 gram per mole, and that will be equal to 2.16 gram per mole. Then, if we're going to compute the product of atomic number of oxygen, which is 1, to its atomic mass, which is 16.0 gram per mole, it will be equal to 16.0 gram per mole. After getting the molar mass of each element, let's now add them. So, we will add 2.16 gram per mole and 16.0 gram per mole. And that will be equal to 18.16 gram per mole. And that will be the molar mass or mass of water compound. Now, let's use the formula mass percent equals to mass of element divided by mass of compound multiplied by 100%. Let's substitute the givens to the formula. Let's compute first the mass percent of hydrogen. So, the mass element of hydrogen is 2.16 gram per mole. Then divide it to the molar mass or mass of water compound which is 18.16 gram per mole, and then multiply the answer to 100%. If you're going to compute that, the answer will be 12%. Now, let's get the mass percent of oxygen. Let's substitute the mass of element, which is 16.0 gram per mole, and divide it to the molar mass or mass of water compound, which is 18.16 gram per mole, and multiply it to 100%. Then, we will have an answer which is 88%. As you can see, the unit left for the mass percent of each elements is percent, because the gram per mole unit will be cancelled. Then, if we are going to sum up the percentage of each element, the hydrogen, which is 12%, and the oxygen, which is 88%, we will get 100%, as pertaining to the definition of the percentage. Let's now proceed to sample problem number 2, which is the sodium chloride. The sodium chloride is composed of two elements, the sodium and chlorine, which have a symbol of Na and Cl. The next thing that we need to do after identifying the elements of sodium chloride is to identify the number of atoms of each of these elements. As we can see, there is no subscript to the chemical formula of sodium chloride, which indicates that the sodium and chlorine is only having one atom. After identifying the elements and the number of atoms that they consist, let's now identify the atomic mass of them. In here, the atomic masses of both of these elements are given. In sodium, we have 23.0 gram per mole as its atomic mass, while the chlorine is having a mass of 35.45 gram per mole. After that, let's now get the molar mass of each element and the whole compound by multiplying the number of atoms of each element to its atomic mass. So, we will multiply 1 to the atomic mass of sodium, which is 23.0 gram per mole, and that will be equal to 23.0 gram per mole. And let's multiply the number of atom of fluorine, which is 1, to its atomic mass, which is 35.45 gram per mole. And that will be equal to 35.45 gram per mole. After getting that, let's now add them. So we will add 23.0 gram per mole and 35.45 gram per mole. And that will be equal to 58.45 gram per mole. And that will be the molar mass or mass of compound sodium chloride. Then, let's use the formula. Mass percent equals to mass of element divided by mass of compound multiplied by 100%. Let's now substitute the givens to this formula. First, let's compute the mass percent of sodium. So we will have the mass of element, which is 23.0 gram per mole, divide it to the mass of compound, which is 58.45 gram per mole, and multiply the answer to 100%. So if you're going to compute that, the answer will be 39.35%. Then next, let's compute the mass percent of chlorine. Let's substitute the mass of element, which is 35.45 gram per mole, and the mass of compound, which is 58.45 gram per mole, and multiply it to 100%. And that will be equal to 60.65%. Just like our first example, as you can see, the unit left for mass percent of the elements sodium and chlorine is percent. It's because the unit gram per mole will be cancelled. And now, if you are going to sum up the mass percent of sodium, which is 39.35%, and the mass percent of chlorine, which is 60.65%, we will get 100% as pertaining to the definition of percentage. We are now done with the discussions of calculations of percentage composition of compounds. It is now your turn. Answer exercise number 3 by determining the percentage composition of ammonia with the chemical formula of NH3 with an atomic mass of 14.0 gram per mole for nitrogen and 1.008 gram per mole for hydrogen. You will have 3 minutes to answer it. You may pause this video and proceed to your computations and go back again here after 3 minutes. Let's now check your answer. If you have this kind of solutions, you are doing the right thing. If you get a molar mass for ammonia, which is 17.024 gram per mole, and a mass percent for nitrogen, which is 82.24%, and mass percent for hydrogen, which is 17.76%, you are correct. Congratulations for a job well done. We can now conclude that percentage composition is important because it allows us to determine the percentage of each element that makes up a specific compound. So that's all for today. I hope that you learned something from our lesson so that you may now proceed in answering your module. Thank you